Hello class. Today we're going to do part 2 of the 2-day lesson over similar figures. So yesterday we began a lesson talking about this particular standard, dealing with proportionality. We were going to generalize the critical attributes of similarity. Okay, so yesterday we found out that there were 4 basic characteristics of similar figures. Figures had to have the same shape, they were of different size, corresponding angles were going to be congruent, and corresponding sides were going to be proportional. Well, today what we're going to look at is we're going to know that the figures are similar, and we're going to use ratios to determine missing parts. Okay? So the first thing that we need to look at today is, how do I solve a proportion? This is something that we're going to have to review. So if we were to look at this first question, okay, there are a couple of ways that we can actually solve this one. In the past, what you've learned is that we can cross multiply. Right? So I would take this 4, I'd multiply by 75, and then we would divide by the 25. Okay, so that's one way that we could actually do this one. Okay, so we could take K is equal to 4 times 75 divided by 25. So in this particular case, K would be equal to 12 if you actually work that problem out. Now there are some other ways that we can work this problem as well. You could probably see that there's a relationship between the 75 and the 25. If I were to divide 75 by 25, I would get 3 as an answer. So that tells me that if I multiply 25 by 3, I get 75. So if I do that in this ratio, I should be able to do that in this one as well. So 4 times 3 then would give me 12. Okay? You can also see a horizontal relationship, like in problem number 2. So what did I do to 6 to turn it into a 24? Multiply by 4. So I could do the same thing to the 19 and get an answer as well. Okay, so when we're dealing with proportions or similar figures, okay, all those ratios can work. Okay, and that's what we're looking for. So today what we're going to look at, we will have, it says we're going to learn to use similar figures to find unknown lengths. So today we know our figures are going to be similar, so they will meet those 4 conditions. Now we're going to also use a technique called indirect measurement in order to find some of our answers. Okay, so this is what indirect measurement is all about. It says indirect measurement is a method of using proportions to find an unknown length or distance in similar figures. Now, one of the ways that you can use indirect measurement, have you ever been walking outside and you saw a really tall tree and wondered how tall that tree was? Well, we can actually use a proportion to find out approximately how tall it is if it's a sunny day. So let's take, for example, that you are, this would be you, a little stick figure there, and let's say that you are about 5 foot tall. Okay, well, on a sunny day, sun is way up here, it shines down and it casts a shadow. You will cast a shadow. Let's say your shadow is 4 feet long. Well, because of the height of that sun, that if I have a tree and I want to know how tall it is, that shadow is also, or that tree is also going to cast a shadow. So let's say that shadow casts a 40-foot shadow. All right, well, what I'm looking for then is I've got a height of 5 and a shadow of 4, which makes a nice pretty triangle. Well, here I've got a shadow of 40. Well, I'm looking for how tall this tree is. Well, it also makes a shadow. Okay, that tree, it also makes a triangle that we can use to solve for how tall this tree is approximately. So I know this piece, I know the shadow, and the shadow, so I could set up a proportion of 4 over 40 is equal to the height of the person over the height of the tree. And we could solve that proportion to find out approximately how tall that tree is. And we find out that it would be approximately 50 feet tall. And that is a form of indirect measurement, using similar figures to find out how tall that tree is. Okay, so our objective today is to be able to look at 2 similar figures, set up a proportion to find the unknown measurement. So here's our first problem. So it says find the unknown length in the similar figures. So we know that rectangle ABDC is similar to triangle QRTS. We know that. So it meets those 4 conditions. And the main one that we're looking for is corresponding parts are proportional. So that means I can look for a pair of corresponding parts that I know the information about. So I know in AC, this rectangle here, AC is 12, and its corresponding part in the other shape is 48. So I can set up a ratio of 12 over 48 is equal to, now I went little figure to big figure. So that means in order to find the other ratio, we need to go the same direction, little figure to big figure. Okay, so I found a pair that I knew both pieces. Now I'm looking for, okay, what do I want to know? I want to know this W in the big shape. Well, what is its corresponding part? Its corresponding part is the 14. Okay, so if I go little to big, then I'm going to go little to big in this one. And now I can cross multiply that one and divide. So I would do W is equal to this 14. You take the number that's with our letter, multiply it by its cross product number. We cross multiply it here, and then we divide by the number that's left, which is the 12. Okay? So if we do that one, we end up with an answer of, okay, and you should end up with, I believe it's 56. That would be 56 centimeters. All right? Now, one other way that you could do this, got the same proportion. Ask yourself, what did I do to 12 in order to get 48? Well, I multiplied it by 4, so I would multiply the 14 by 4 as well, and you'd get the same answer. Now, another way we could look at this proportion is I can use the two pieces in the shape itself. So I could set this up as 12 over 14. So I did AC over AB, so I would do the same proportional pieces over here, corresponding parts, QS over QR, which would be 48 over W. And now we're looking at how did I go from 12 to 48? I still multiplied by 4. I do the same thing to the 14. So there are several ways of setting up the proportion. As long as you go the same direction and use the same corresponding parts, it should work. Okay, so let's look at another one together, and then I'll have you do one by yourself. Okay, so here's one. It says city officials want to know the height of a traffic light. Estimate the height of the traffic light. Now, sometimes when you're given shapes like this, it's kind of hard to see the figures. Okay, so in this one right here, we actually have a small triangle that is working with this side, and then we have a big triangle that's dealing with our traffic light. Okay, so what we're looking for here then is to set up our corresponding parts. So I know this 27.25 corresponds to the 48.75. So we could write it as 27.25 divided by 48.75 is equal to, so I did little to big. So now if I do the same thing with the other ratio, I've got little, which is the 15, divided by the H, which is the big. And we could solve that one by doing H is equal to 15 times 48.75 divided by 27.25. And you'd end up with H is equal to, and it's a really ugly number, but if we were to round that number when we type that in, if we were to round it to the nearest tenth, you should end up with, I believe, 27, you should end up with 26.8, approximately 26.8 feet tall. Okay, so that's one way you could set this one up. You could have also done 15 over H is equal to 27.25 over 48.75, or you could have done 15 over 27.25 is equal to H over 48.75. And any which way you work it, you should, as long as you use your corresponding parts, it should give you the correct answer. So let me have you do one on your own. This one's going to be a little bit trickier, but let's see what you can do. It says triangle RST. So when they give you this, you might want to actually highlight the shapes that we're talking about. RST is similar to triangle PSU. Okay, so PSU is the big one. Okay, and what we're looking for is D right here. Okay, so take just a moment, pause the video, and take a moment and see if you can set up your proportion and solve for D. Okay, let's see how you did, because there's one part in this particular problem that's kind of tricky. Okay, so let's set up our parts. So let's start with our little triangle and go to the big triangle. So here we got a little triangle here. And what parts do I actually know? Okay, well, I know this piece right here corresponds to this whole piece right here, okay? So in order to actually put those numbers down, you know, we might get tricked into thinking that it's 12 over 9, but it's really not. If we do the small figure, let me get rid of that color there. If we do the small figure, which is 12, okay, over the big figure, we know that that's the whole piece. So I got to put the 12 and the 9 together to give me 21 is equal to, so I did little figure, big figure. So little figure is the 14 over the big figure, which is the D. Okay, so in this one right here, what we're going to do is D is equal to 14 times 21 divided by 12. So if we take a calculator and we type that in, you would end up with 14 times 21 divided by 12 as I'm typing it in on mine. And we end up with D is equal to 24.5. And in this case, we don't have anything, so just units. All right? But the tricky part on a problem like this is realizing that this 12 and this 9, this other side here is not just 9, that we have to put those pieces together. Okay? So the whole point of today's lesson was to learn how to set up the proportions and solve for the unknown. And that's what I'm going to have you do on your assignment today.